lack of time.
Well, now we are back on time, but it depends on you how you see it.
No, it's not mine.
Sorry. We had it
Yes.
ready here. Yeah.
Okay.
And this one. You just
Okay. Good morning, everyone. My name is Goran Cetkovic from National Climate Service of Serbia Research Department. And here are more or less people who are involved in all this story behind the, well, let's say, making a new modeling system for specifically for the Icelandic dust transport. I will try to briefly explain what is going on. So this is a fully coupled dynamic model, which is actually, we have separate numerical models for simulation of climate system components. So you have atmospheric part of the model, which is non-hydrostatic model, and then the dust model. And these two interacts, they are dynamically coupled. So in each of these grid boxes, every of these equations are, let's say, solved in each time step, and these grid boxes actually communicate in each time step in the model. So to understand and to model the hours of the dust transport, the model has to be good enough to really good represent the wide spectrum of processes, starting with the surface deposition, emission, surface deposition, turbulent mixing, and all the way up to the long-range transport and climate impacts. And that actually explains the complexity of the problem. So the proper simulation of especially these small-scale dust events is really demanding in terms of enormous increase in computational power. Just for instance, if you run global model, dust transport model on 40 kilometers, like this one in ECMWF, if you want just to have a double better resolution, you would need 16 more time computational power. Imagine to go from 40 kilometers to 3.5 kilometers. It's insane. So because of that, the dust modeling divided typically in 3 branches with coarse, relatively coarse global models of, let's say, 20, 30 kilometer resolution. And then really, I would say, coarse regional models. And the third branch, which we are doing, is very short range transport and with very high resolution modeling. So to illustrate what I said, it was intensive local dust storm in Iceland in July 2022. On the left side, there are the plots of the global model comes EFS model around 40 kilometer resolution. And as you can see, no signal of dust over Iceland. On the other side, here in NMM Dream, our model, you can see activation of several dust hotspots, which Charlie presented before. So what's behind this story? Among other research motivations to do this job, one of the most significant was that we really wanted to develop a system which is capable to forecast these events and to be used as both as early warning system, but also for the climate assessment. So this is the schematic representation of the model in which this equation for the dust concentration is solved in each model step and each grid point. So model is driven by the non-hydrostatic atmospheric model. It simulates all major processes like emissions from the ground, turbulent diffusion, and such, dry deposition, wet deposition, and long-range transport. It includes 8 different beams, and for the first time, it includes the variable particle size distribution for each of the dust sources. Typically, all the models in the world use just one and the same particle size distribution for the whole domain. Here it's variable. And also we improved the emission by including the active snow cover and soil moisture in the model. So this is the model domain, wider than only Iceland. So we can frequently observe the dust transfer for these sources to the UK and Ireland. So the first thing, a very, very crucial thing is preprocessing. It is very important to define the dust sources. And to do that, you need to use wide spectrum of information, starting with length cover, with textures, with silt and clay content in dead soils. Then another relevant information is like albedo, like soil moisture, etc., like NDVI, EVI indices. In other words, vegetation cover over these sources. And instead of using some climatological values in model. So we prepared dust mask on model grid and also included the dust hotspots that Ollie said. These hotspots are actually the area that emit by far more dust than the other regions in Iceland. So special thanks to Ollie and Pablo for all the input and work and discussion that led to this. Okay. As I said, implemented variable particle size distribution and active soil moisture and snow cover. So the starting point was to integrate the information of soil erodibility from Arnold's in his paper 2010. So this erodibility map, we choose three, let's say, regions, three classes, no regions. Extreme, which is orange, severe erodibility, which is green, considerable, which is blue, and these yellow circles here represent the hotspots. After remapping in model, here you can see how the dust source map is represented in the model in two different resolutions, coarser and finer resolution. So we can see clearly better representation of fine hotspots here as you go to the finer resolution. Another thing was that based on the measurements from the campaigns, we implemented all the information of silt and clay content in model. And the third story is that, as I said, conventional PSD, particle size distribution, says that you use in each grid point, each particle size distribution. We know that there are a lot of differences among the dust hotspots. So based on the observed parameters, observed diameters, we implemented for each dust hotspot its own particle size distribution. So in other words, how the mass is distributed over the bins. And finally, some results. This became the first operational model for forecast Icelandic dustic dust back in 2018. This was September 2011. The whole last episode started something like on 8th or 9th of September, lasting for 5 or 6 days. But the peak in concentration are observed at 12th of September. On the upper plots, you can see here the dust plum. This is MODIS visible spectre. This is AOD, suggesting the dust plum. And here, this is the surface concentration from our model, 3 consecutive days. In order to further validate what's happening in the vertical, let's say, section, we use Calypso data. So red line here represents the Calypso path. And this plot here represents the time and cross-section towards that, let's say, part of the Calypso. The first thing is dust concentration from G model. Reykjavik is here. The second plot is Calypso feature type 3, which means aerosol. So we concluded that, yes, this is dust, really, over the Reykjavik. And then Calypso Calliope subtype 3, which is dust. This is the ground measurements, PM10. You can see that Jim are the blue bars, the orange bars observed PM, but look at this, this is hourly averaged observed, and this is Jim at full hour. So differences are between averaging this data over 1 hour, and this is just direct model output at the same, at the first hour, second hour, etc. But nevertheless, the patterns are here. So model is able to forecast sudden increase in concentrations up to 200 micrograms, and also sudden decrease. So it's good when your model is able to settle down all these particles up that. And I keep in mind that something which is called double penalty problem. So this is, let's say, coarse resolution model. This is fine resolution model. And if you have fine structures outside narrow, let's say, dust plum, and your observed site is somehow shifted, let's say, and not just over your plum, it will produce false alarm. So although your forecast is really good, the observation point, because of some displacements of kilometer or 2, will give you the worst, results. But if you have a coarse resolution, you will hit for sure some concentrations. No so high, but you will. So keep in mind when going to the really high resolution, that problem of double penalty. Another was, okay, this worked for the short range transport. This is the case of long range transport. On the top plots, left and right, here is also clearly visible the dust plum from the south of the Iceland. Here also AOD. And these are the prognostic, the forecasted fields from our model. So you can see this orbiting cyclone here over the Faroe Islands is also really catched here with AOD in satellite pictures. So position of the plum, and we concluded that yes, position is good, and also these particles travels all the way down to the UK and Ireland. And then the most recent verification was during last year, 2024. Pavla set and her friends set the observation point somewhere in the south of the Iceland. So we said, okay, let's compare CAMS and JIM forecasts for that specific, let's say, observational point. So we used data from actually 2 case studies, one in April, several days, and the other case study was the whole of June of that year. So CAMS model is 40 kilometer resolution. And it does not include local dust sources. So basically everything that comes transported to Iceland is from somewhere. It's not lifted in Iceland. They do not have that sources there, neither in the most of the Arctic region. In our model, which is, let's say, which is limited area domain, high resolution model, with included dust hotspots and sources, and with 3.5 kilometer resolution, in which you can really properly forecast the things, small scale, intense things. And here are the results. Few days in April, the yellow is observation, PM10, 5-minute frequency. The black line is model, but on every third hour, direct model output. So I didn't bother that with averaging and such and such. I think that these lines would fit it even better with averaging and moving averaging and etc. But it's fine enough. You can see that clearly that we are able to focus this peak of dust storm and then removal of particles from the atmosphere and then quiet period and then again another dust storm. Okay. And whole June, this is observations, this is our model, and this is camps. You can see clearly that almost all of these dust storms in that stations are represented and forecasted by the model. We can discuss about some concentrations, but every dust storm is catched here. And particular thing here on the 5th of June, equipment stopped. So we do not have measurements at that 5th of June, but we have model results here. And then that's one thing. These are the U component of wind from ECMWF. So choose wisely the position on your station. If your station is to the east from the dust source, you have to deal with winds, prevailed winds during month. So if you had this hotspot, all winds from here will not be catch if you have here instrument. If you have, you know, what's the point? So you have to position your equipment ideally in the center of the dust hotspot. That's our meaning. But on the other hand, the global models like CAMS and other models, and now we also have our version of long-range transport model, are good because they can add to the story the transport from the North of Africa. So that's the, let's say, compatibility and complementarity of this system. And just 1 minute, please. Our future plans, we also made the model for darkness based on this. So this is model result surface concentration. And this is so-called model darkness, which represent transport of the property, not just the concentration, but the property of the matter. And after 5 days of dust storms, here, this is our deposited darkness. This is the glacier, and this is why glacier. And you can see clearly, this is dust, clear dust. Dust, clear dust. Circumpolar version of model, already said with my colleague Anna Vukovic, we implemented those masks to our circumpolar model. So this is the animation from the emissions from both Greenland, but also the Iceland. This is somehow visualization from AOD from the satellites, catch these all patterns, and that would be all from my side. And thank you.
Great. And so we have time for one super quick question. Yes, so I see one is online. So Neil, please. Sorry, Norm. Norm, you can raise your question.
Yes, very interesting talk. I was wondering about the contribution of fine mode. Maybe we don't have the same definition of fine mode. Submicron dust, is that an important part of your model? And I have a second question. Maybe it's not fair, but maybe it's in general. I wondered how fast algae would react to deposition on the water. In other words, how quickly would you see a green signal in the imagery?
The first, if I correctly understood the first question, yes, our model used the 8 particles bins from submicron up to 9 micron.
Okay, and how important is the submicron component?
Really, because the submicron component can be, and it's transporting to the long range transport. You know, the bigger particles will settle down, let's say 100 kilometers from source. But once when you have the very fine particles, which luckily are lifted up in some cumulus convection of both satellite to the mid-atmosphere winds, these submicron particles can travel a lot of distances.
What sort of optical depths do you simulate or see?
Sorry?
What sort of optical depths do you associate with the fine mode do you simulate or measure?
What sort of optical depths you use for your simulation?
Yeah, we use AOD. If you
I understand that, but what sort of optical depths are associated with the fine mode?
What source is associated with fine mode? Like
505 nanometers, you miss AOD. I don't know. I cannot.
I mean, how do you? What is the threshold between fine mode and coarse mode, and which part is fine mode, and what is the source of that fine mode?
Actually, when calculating the AOD, we assume that all particles are in our model is, let's say, fine mode, because are from 2 to 9 microns, you know. So actually, when we just how to say summarize or collect all the bins and then verify again the AOD. And the second question that you stated, it's special. It's not working with this kind of model. We have a model so-called iron model, in which have the iron component, and this component has in this model have a solubility of iron, you know, because of different things like radiation, like pollution, like being processed in the clouds, etc. So you know you have the decay rate, and then we have model cow that actually settle down on the oceans through the depth, dry and wet deposition. But usually 5 or 7 days after the deposition, you can observe the algae boom and growth, etc.
Oh, is that right? 5 or 7 days.
At least for Cape Verde that we run the model for that region. Also depends on the temperature of the water, etc., etc.
Okay, thank you.
So thank you for having me speaker. And so there are additional at least 4 questions for Bojan on the chat. So Bojan, could you please directly answer it in the chat, because you have many questions. Bojan, can you answer the questions in the chat? You have at least 4 more questions. Thank you. And now we will continue to our next speaker, which is Mark Barrington, and he will also talk about long-range transport, actually, of low-latitude dust, possibly to Iceland and high latitudes. So, okay, Mark, the floor is yours.
Okay, thanks, Pavla. So can I just confirm you can hear me okay, and you can see my presentation in full screen?
We do, thank you.
On the screen behind you, yeah. Okay, so yeah, so thanks, Pavla, for the opportunity to just give it's going to be quite a quick presentation, I think, and I think a lot of what Bojan just presented, I'm going to kind of repeat a little bit because I'm going to talk specifically about the CAMS global forecast system, and yeah, just to have a look at the same case. But at the end, I also talk a little bit about maybe some smoke transport, I think, based on some of the discussion and the things that were presented yesterday, just in case this is also of interest for this community. Okay, yeah, so I work at ECMWF. I'm part of the CAMS section there, and of course, this is all work that builds on a lot of expertise from colleagues both at ECMWF, and some of what I'll present is maybe a bit of a prelude to what Samuel Remy will talk about this afternoon, and also addresses one of the points that Bojan just made. Okay, so yeah, so just a very quickly overview of Copernicus Atmosphere Monitoring Service, just in case anybody isn't aware of who we are. So the EU runs its the Copernicus program, and CAMS is one of 6 data services, along with the others that are listed here. And at ECMWF, we're implementing climate change atmosphere monitoring services, and we also contribute to the emergency management service. So in terms of CAMS specifically, all the information can be found on our website. We have a wide range of products all related to global atmospheric composition, air quality, but also air quality for the European domain. And then this feeds into a lot of policy tools and things like solar radiation, greenhouse gas emissions monitoring is starting to really ramp up and become a significant part of what we do too. But I'm going to focus on having a look at these cases with our global system, as I mentioned. So Bojan gave a few brief details about CAMS. We're running, as I said, a global system, which is the main work that we do at ECMWF. So we're running the integrated forecast system, which is global, 40 kilometer by 40 kilometer effective spatial resolution. It includes all the NWP and the simulation of all the NWP observations. And then, of course, for CAMS, we have all the chemical source and sink terms and the tendencies, and also a simulation of satellite observations for atmospheric composition. And the most relevant here is at aerosol optical depth. I'm not going to go into the details, but if anyone's interested on exactly what observations we're simulating, I'll be happy to answer offline later on. And yeah, this global system then provides lateral boundary conditions for a suite of 11 regional chemistry transport models, which run at 10 kilometer spatial resolution. And also, I didn't get around to looking at the case that I'll show for these models, but there's also some prospects for using this output for evaluating dust transport episodes for Iceland. And then also we have surface air quality observations where possible, and this feeds into our evaluation, validation, as well as a simulation for the regional system. So maybe skip that and just get to the sort of the analysis. So yeah, so Pavla showed this slide yesterday, and I think we just saw it in the previous talk as well. So this dust transport episode from the Sahara reaching Iceland in mid-November 2024, and the examples at the back here show the outputs from the Monarch model, the dust load, and then some examples of the measurements. I don't remember from the site in Northeast Iceland, that's shown here. So we've already seen these, and we had a meeting with Pavla and some others a few weeks ago, and it got me thinking. As part of my day-to-day work, I'm looking at these kind of atmospheric pollution events, so dust storms, fire emissions, smoke transport, volcanic eruptions, general air quality, and this was something that came in during a period when I was out of the office, and so I never picked up on it, but it sort of prompted me to revisit it with the products that we have. And so I started off looking at the similar things to what Bojan just showed, so looking at the surface PM10. So on the left-hand side, I'm showing the total AOD, and this is the forecast from the 12th of November, and the output's valid at 0600 UTC. And so we can see this plume in AOD. It's not particularly strong, reaching Iceland. So the max AOD values here are at 0.5, and so it's not, yeah, like I said, not particularly strong. And if we look at the surface PM10, then we see that, yeah, the plume is there. There's some enhanced values, maybe up to 70, 80 micrograms per centimeter cubed. But we see that there's generally there's not much over Iceland itself. And in the middle here, if I compare the observations from this site in the northeast of Iceland, and be careful not to embarrass myself with mispronouncing the name. This is the measurements from the 11th, 12th, and 13th of November. So we see up to about 200 micrograms per meter cubed of PM10, and in the CAMS global PM10 surface concentration, there's some enhancement, but it's considerably lower, and in fact, I would say there's not really much of an enhancement there during these days in the PM10. And I think this could be because of how the model level definitions are assigned and how the surface PM10 calculation is made. So we only provide PM10 at the surface level, But of course, we have the dust mixing ratios. And so if we switch to looking at the dust mixing ratios at different levels, then we start to see a bit more of the plume, and we start to see a bit more of an enhancement of Iceland itself. And here in those same days, if we look at the dust concentration, this is from the 3 size bins that we have added together, then we start to see a much clearer enhancement and signal at this location, but still probably underestimated compared to what the measurement showed. So I think, yeah, the signals are there, but it's just a question of the context and manipulating the data to be able to see what we want to see at a particular location, and taking into account perhaps the elevation of the measurement station and the elevation of the Iceland landmass, which might prevent what we have in our surface concentrations reaching the measurement sites. I also had a quick look at the deposition fluxes that we have for dust, and this is looking at the four main components for the same day. So this is a daily total valid for the 12th of November, and so we can see also quite clearly there is a signal of dust from this plume reaching Iceland and the high latitudes under different conditions. But still, some work is needed to better evaluate and to understand any deficiencies and what could be done to improve those deficiencies relative to what's measured. So that's it's very rough and very high level. I've not had time to go into this in any detailed way, but just to take a look at this particular case, and I think, as I said, sort of reiterate what Bojan just presented. And in terms of the regional dust sources, then Sam Remy will talk about developments for this in the next talk after lunch. But I just want to spend a few additional minutes to look at other work that I've done in the past, which has been looking more at smoke transport and aerosol, smoke aerosols reaching high latitudes, particularly within the Greenland European domain. And just in case there's an opportunity to make connections to others taking part in the workshop who might have measurements that are relevant for evaluating these aspects as well. So I'm just going to walk through a couple of quick cases. So this is an example of smoke transport from Canadian fires in the summer of 2023. So we can see the plume developing from Northwest Territories, Western Canada, and then heading out towards Greenland, where on the right, I'm looking at now black carbon total deposition over Greenland in relation to a plume transport reaching Greenland. And so this is some work in progress that I've been looking at for quite a few years, and trying to look at different plume transport episodes and trying to understand this. So this is one element where it would be interesting to know if anybody has measurements of aerosols or deposition fluxes that would be useful for evaluating these data. And also aspects of smoke transport related to impacts on atmospheric radiation and potentially NWP. So this is a case from a lot of years ago, from July 2015. And this was a smoke transport episode coming from Alaska over the eastern half of the Arctic and reaching Svalbard. And so again, similar to some of the haze photos and that we saw yesterday, these are two photographs from the Zeppelin station, I think, looking at that in the same direction on 2 different days and successive days, and we can see very clearly hazy conditions in relation to this smoke transport. Svalbard is quite decent location for evaluating our forecasts, as there's a couple of aeronet sites and there's also some measurement sites, and these 2 panels on the right are showing the AOD during these days, and also some surface carbon monoxide to show that this plume was also detected there at Svalbard. And then just to follow on from that, this is an animation showing the estimated shortwave radiation differences relative to a climatology for this case study. So we can see there the plume crossing the eastern half of the Arctic, and so this is sort of still a work in development, and like I said, this is from 2015, so now it's nearly 9 years that I've been kind of slowly building up this information and looking at different years to look at similar cases. And then this, maybe I'll skip over this. This is looking at a couple of different years, but just to get to some other high latitude transport episodes. So here's huge fires that were in Canada in 2017. So this is August 2017, just to show this high latitude plume transport and evaluation against some of the aeronet sites related to that plume transport. And similarly to what I showed for 2015, this is the impacts then on the shortwave radiation fluxes. So that's just a kind of a very quick tour of some aspects of looking at long-range transport of aerosols into the high latitudes from dust and from fire emissions. And so in summary, we'll hear after lunch about the developments for including high latitude dust sources in the CAMS global system. We're seeing there's some challenges in evaluating these dust transport episodes from the Sahara. There is a signal there, but the enhancements are maybe not so realistic compared to what's being measured. And maybe for some of the challenges that were pointed out in the previous presentation, there's some processes maybe that are difficult to represent fully in a global operational system. And so but at least we know where we stand, and the measurements that Pavla and her collaborators have been making in Iceland through the NCP, I think, are going to be essential to evaluating and improving our system. And then just finally, so smoke transport seems to be better represented. And I think this plus high latitude dust sources will generally lead to us having better representation of aerosols at higher latitudes, which would then have benefits for NWP as well as the atmospheric composition monitoring. So that, I'll thank you for your attention and take any questions.
Thank you very much, Mark, for this really interesting talk. And I would just add personally, so I would like to also acknowledge the CAMS NCP Iceland for actually allow us to fill this gap in the measurement stations for Iceland. Although, of course, it's very challenging to maintain the long-year measurements, but I'm very proud that we did it. And with the black carbon cases you showed, we have also, let's call it, estimates of the increased black carbon concentrations using the light aerosol optical counter. So since, unfortunately, not July 2023, but since autumn 2023, we can always also look backwards for these increased concentrations, because the instrument can really, based on the typology, estimate if it was black carbon or dust. And there is also one carbon monoxide station in Iceland. So you can find these data for the long-range transport of the fire emissions quite backwards. And the Saharan dust event, so on average, based on the paper of Varga et al. 2019, there is 1.5 Saharan dust events per year, but now we are actually looking for longer time period, up to 40 years backwards. And it is higher, because just last year we have noticed 3, but there are probably more. Those are not really visible. But sorry for taking the time, and we will take. Hopefully, you can take the questions. So, are there questions here in the room? Not yet. So I will open the chat, and just feel free just to raise the questions yourself. You can unmute yourself. That will be the best. So please, Norm.
That's very interesting, that simulation from Alaskan smoke all the way to Svalbard. it would be interesting to watch, to observe the change in particle size that we can compute from the AeroNet data, maybe in Alaska and as well at Svalbard. It looks like a very interesting case to me.
Yeah, thanks, Tom. Yeah, it was an interesting case. I mean, I think it was the first case where I started doing this kind of more day-to-day routine monitoring work, and I just started work on I just changed my position to start working on the development of the GFAS fire emissions, and so it sort of tied in with that, and I think, yeah, we focus more on the radiation impacts. I'm not sure that there was too many other AeroNet measurements at that time, but also because we have a reanalysis, so we have these events, I've been looking at the year-to-year similar transport episodes, and so maybe some of those would have some prospects for doing that, or maybe these smoke plumes that follow the polar jet routes via southern Greenland and up towards the Norwegian Sea. In that way, maybe we have a better chance with those because there's a lot more sites underneath the trajectory.
Well, we could have a quick look just to see if there's anything interesting that happened in terms of the fine mode particle size evolution.
Yeah, agreed. Yeah, sounds good. Thanks.
Thank you. And maybe Santiago, do you want to raise your question? Yeah, I believe it's really early at Santiago's side now. So he's asking, I would think that with so much high latitude smoke from long range transport, the signal should show up in filter measurements at the surface of Iceland. So is there any evidence of smoke from long range transport in the air quality surface network in Iceland?
That's a question for me. I don't know, but
Yeah,
I think prompted by Sylvia's presentation yesterday, and Santiago also asking about the possibility of any sort of smoke particle measurements. I think that's why I added that into the slide deck, just to see if, I think, okay, we're talking about dust, but I think aerosols in general, it's a good opportunity to maybe consolidate some of those and bring together. So I'd like to know as well if that's the case.
Yeah, so if I can answer from my personal experience, we have this air quality network stations here, and I mean, you can see the smoke even visible. Sometimes you can even smell it. So these events are then on news and you can see it. So you can check backwards. It's at the moment, the website is loftgaedip.is, but we are moving all this information from CAMS, but in situ stations into one new website, like web application. And Hlinur Arnarsson will talk about it at 13:45. So if there are no questions, let's thank to Mark and also all the speakers of this morning session. And we will continue this CAM session, but also include the first part of the CAM session and the new air quality web page at 1 o'clock Icelandic time. So see you then. Thank you.